Hi, my name is Jamie Holchin, and today I'm presenting on the results of the article Intermittent Hypoxia Promotes Melanoma Lung Metastasis via Oxidative Stress and Inflammation Responses in a Mouse Model of Obstructive Sleep Apnea. So, this research explores the effects that intermittent hypoxic state occurring from obstructive sleep apnea has on cancer growth. It is supposed that OSA-like IH causes the period of post-hypoxic reoxygenation, in which inflammation occurs and reactive oxidative species form. This in turn is linked to cancer metastasis. Therefore, the objectives of this experiment are to investigate how induced OSA-like IH affects melanoma metastasis in the lungs of mice. In addition, the study considers the use of Tempol, which is an antioxidant, to possibly prevent the metastasis of these lung tumors. So to obtain the results of the experiment, the study used 8-week-old mice, and they were split up into 3 groups. Group N, which were handled in normal conditions, Group IH, which were treated with intermittent hypoxic conditions, and Group IHT, which were treated with intermittent hypoxic conditions, as well as administered Tempol daily. And so moving on to the results, we can see in Figure 1, this shows the lungs of the mice of all 3 groups, and it shows how OSA-like intermittent hypoxia affected melanoma metastasis. And so you can see the little black dots are the cancerous colonies. And all groups were given melanoma, but it appears that Group N had the smallest or least amount of cancer colonies, as opposed to Group IH and IHT. And Figure 2 goes along with Figure 1. This is where the lungs of the mice were actually individually observed for the number and size of melanoma colonies. And Figure 2a shows the number of colonies present on the lungs. And as you can see, the Group IH had a significantly higher amount than Group N. This signifies that intermittent hypoxia does play a role in cancer metastasis. And also, the IHT group shows a lowered level of number of colonies on the lungs, which indicates that Tempol does play a role in preventing metastasis in some way. Same thing could be said for Figure 2b. And this is the weight of the colonies, and we can see an increased weight of colonies in the IH group, indicating metastasis did occur, and then a lowered amount in the IHT group, indicating that Tempol did somehow prevent tumor metastasis. Moving on to Figure 3, we see the levels of oxidative species present within the lung melanoma cells of mice. And so we know that high levels of ROS are tied to tumor metastasis, and we can see here that Group IH had a significantly increased levels of ROS generation, which indicates that tumor metastasis was instigated in the intermittent hypoxic conditions. Again, we see with the IHT that there are lower levels of ROS generation present, which indicates that Tempol, which is an antioxidant, did help prevent reactive oxidative species. And so altogether, all these results work together to really show that oxidative stress and ROS generation induced by obstructive sleep apnea, like intermittent hypoxia, plays a major role in tumor growth and metastasis. And Tempol, we see, also worked well to prevent tumor growth and metastasis and may be used in the future to help prevent certain types of cancer with this condition of obstructive sleep apnea. And that's pretty much all I got for you. So thank you for listening.